Today we're going to look at how to name benzene molecules, or what we call benzene nomenclature. And here we're going to look at benzene as well as groups that we can put on benzene and see how we can name these things. So let's start off with some of the simplest ones. Here we'll call these monosubstituted benzenes, where we have just one group on the benzene molecule. And when we name benzene molecules, what we will typically do is just draw the circle inside benzene just to make it easier to draw. So if you had a bromine on the benzene, just like you might think of how to name it, you would just put bromo in front of benzene, so you'd have bromobenzene. Here's a very important group on benzene, NO2, that's called the nitro group. So that gives us nitrobenzene. And the list goes on. You can have an ethyl group on there. And so have ethylbenzene. So these are ones just to get us warmed up with. Up here with the bromobenzene, we can have the other halogens, so you could have fluorobenzene, chlorobenzene, iodobenzene, and so forth. Okay? So these are the easiest monosubstituted groups to become familiar with. Now what we're going to do is shift gears to look at some other ones. Okay, and these ones here are going to have trivial names to them that you simply have to memorize. Okay, so let me start writing the molecules on the board. Start with this one here first. Here you might be tempted to call that methylbenzene, but here this has a special name. That we call toluene, okay? I know you're tempted to call it toluene, but no, think of a tall person, it's called toluene. We're using that molecule a lot. Here's another important one where we have the OH, so we have an aromatic alcohol. This one here is what's called phenol. Phenol, okay, alcohols generally end with OL, so that's a tip off there. If we have an NH2 on the benzene, this is what's called aniline. Aniline. We could have an OCH3. Note it doesn't matter where I put just one group, I could put it on any one of the carbons, so don't get shook up by that. An OCH3 gives us the molecule anisole. could have an SO3H on there. To give us benzene sulfonic acid. Here we can have the acid group on benzene. And so that gives us benzoic acid. Here we're going to have the aldehyde group on there, C double bond O, then a hydrogen. This is what's called benzaldehyde. Benzaldehyde. Here, if we put a C double bond C on the benzene, we get this very popular molecule called styrene. This is the precursor to making polystyrene, which is found in styrofoam cups and things like that. On this one, we could have a CN group, okay? This is abbreviated, but there is really a triple bond between the carbon and nitrogen. This is called a cyano group on benzene, but this gives us the molecule benzonitrile. Benzonitrile. Okay. Here we can put this carbonyl with a CH3. This is what's called acetophenone. Acetophenone. Okay, so these are the major ones that you want to commit to memory. I would encourage you to put the molecule on one side of a flashcard and put the name on the other side, and that will help you memorize these molecules and their names. Okay? Let me draw another one that's very similar to acetophenone. Where now you have another benzene on the carbonyl. This is what's called benzophenone. Benzophenone. Okay? So all these are in your book, but you want to get these names down and get them down quick, because we'll be referring to their names very often. Okay, so those are the monosubstituted benzenes. Let's go ahead and go on to disubstituted benzenes. when we look at di-substituted benzenes, here we're going to have two groups on the benzene ring. Okay, so when we put two groups, we have to put them on two different carbons. And so we can have one of three arrangements, or what we call one of three different isomers with two groups on there. We have them adjacent or skip a carbon. Or have them on opposite carbons of the benzene. Okay? If they are adjacent to each other, they're called ortho to each other. If they're an extra carbon away, that's called meta. Meta means beyond, so it's beyond the ortho by one. And lastly, you have the para setup. So a para means alongside of, so it's alongside of the meta down here. We will often abbreviate these as O, M, and P isomers, okay? And so this is how we're going to call benzene molecules where we have two groups on the ring. So let's go ahead and look at some examples. Suppose we had two bromines on the ring. Can you see what the name of that would be? Two bromines, dibromo. Then benzene, so dibromobenzene, but what are we missing? We're missing the relationship. They're ortho. So we'll put the O out in front to tell the reader that. So we could have ortho-dibromobenzene, or we could have meta, or we could have had the para isomer. Okay? What about something like this? Here we have a chloro and a nitro. Well, two different groups, so we put them in alphabetical order. So we have chloro-nitrobenzene. But again, what are we missing? The relationship. They are meta to each other, so we have an M in front. So you should be able to draw the ortho isomer and the para isomer as well. Okay? But with the di-substituted ones, okay, we also have some trivial things to look at. For example, how might we name something like this, where we have this methyl and a bromo? Do you remember what the methyl makes the benzene? Yes, it makes the tall person, toluene, and the bromo is para to it. So we would have para, bromo, toluene. So toluene would be the base name, and the para is telling the reader the bromo is para from the CH3. Okay. Let's look at another one. Okay? So do you see what the base name of that would be? Yes, I see the OH to make it phenol. The nitro is what? Ortho meta from it. So we get meta nitro phenol. Okay? So you see the importance of memorizing those monosubstituted trivial names so that you can identify them in di-substituted molecules. Okay? So very important. Okay? So make sure you do your homework problems so that you get more practice with those. I now want to shift our attention to some trivial names that are with di-substituted molecules. Let me show you one to start with here. For example, suppose you had two CH3s on the benzene, two methyl groups. How would we name that? Well, here, the trivial name for two methyl groups is what's called xylene, like a xylophone, xylene. Okay? And so here, the two groups are ortho to each other. So that would be orthoxylene. Okay? So you should be able to draw also metaxylene and paraxylene as well. Okay? Let's look at another trivial one. Let's suppose we had a CH3 and an OH on the molecule. What are we going to have here? This is what's called cresol. Cresol. What kind of cresol do we have? Yes, this is the meta one. So we'll put an M in front. So you should be able to draw also ortho and para cresol. Okay. Let's look at another one. Here we have the acid group and the CH3. This is what's called toluic acid, and they are para to each other. So this would be the para isomer. Okay? So you should be able to also draw the ortho and meta isomers of toluic acid. Okay, so those are the main di-substituted ones that you want to memorize. Okay, let's go on to some other types of naming. Suppose we wanted to name this molecule. Okay? If you note on the benzene ring, you have this long carbon branch that would be very difficult to name. So here we're not going to name it as a benzene molecule. Here we're going to name this as a parent chain. And as a parent chain, there are 6 carbons, and so that gives us hexane. But now, what are we going to call this benzene as a branch on hexane? Okay? As a branch or a group, this is what's called the phenyl group. And that phenyl group is on the 3 carbon. So here we have 3 phenyl hexane. Okay? So here we want to get familiar with what's called the phenyl group. Let's look at another example. Here we have an oxygen with 2 what? Benzene rings, or what we can call 2 phenyl groups. Remember that oxygen with 2 carbon groups on it is an ether. So here we would have diphenyl ether. Okay? So naming it as a phenyl group can be very helpful to us. Okay? Let's look at another example of this stuff. Let's suppose we had this molecule. We got 2 benzene rings attached to each other and a chlorine. How are we going to handle that? Okay. The way we handle that is focus in on the middle benzene. Notice it has the chlorine as a group and what? A phenyl group right here. And they are what to each other? Meta. So here we would have meta-chlorophenylbenzene. Okay? So that's how to handle if I have 2 benzene rings attached to each other. Use the one in the middle, and name one as phenyl and the other as the whatever group it is. If I just had 2 benzene rings attached to each other, this has the trivial name that's called biphenyl. Okay. All right, well, let's look at some other benzene molecules. Here we want to introduce ourselves to something called the benzyl group. The benzyl group is simply when I have a CH2 attached to the benzene ring. So I need to complete the molecule with something. Let's put a chlorine on there. Okay. And the name of this would be benzyl chloride. Okay? So here we're naming the molecule as a chloride, just like if you remember in general chemistry, if you had KCl, that was named as a chloride, that would be what? Potassium chloride. Okay? Let's look at another example with the benzyl. Let's suppose we had an OH there. What could we call that? Well, again, benzyl. And then we can put on alcohol. So that would be benzyl alcohol. Okay. Okay, just to kind of finish this up here, let's look at naming something like this where we have all these groups. Note that we have an OH on the parent chain, so this will be named as an alcohol. So that will get the priority. Since it has priority, we'll name it from, or number from that side. So the chlorine is the lowest in the alphabet. So we would have 5-chloro. Then on the 3 and 4, we have phenyl groups. So we would have 3,4, 2-phenols or diphenyl. And then we have an alcohol on the 2. So the 2 tells me where the OH is for 2-hexanol. So that would be 5-chloro, 3,4-diphenyl, 2-hexanol. Okay? Okay, so let's look at some other naming of benzene molecules. Sometimes you can have some fused aromatic rings together. Okay, so they are fused together. And these have trivial names associated with them. The top one is what's called naphthalene. Naphthalene. This is what's found in mothballs. Okay. The bottom one is what's called anthracene. Anthracene is what's found in hard black coal that's found up in Kentucky and West Virginia, places like that. Okay. So these fused rings are what? Highly, highly unsaturated. Okay? And you can have more and more fused rings together. In fact, the more that you can get together, the more carcinogenic, the more cancer-causing that molecule becomes. And it's these kinds of or what are called aromatic rings that are put together that can form when we burn our food, such as burnt meat and so on the barbecue, that it might taste so good, but yet it can cause a lot of damage in our body. So be careful about burning foods, as fused rings can start being formed there. Okay? Let's look at a couple of other items. Okay? Sometimes we will abbreviate the phenyl group with the letters PH, and so this here would symbolize what? Phenol. Okay. Let's suppose we had a molecule like this, and we wanted to figure out its name. First thing you want to do is look to see if there's any trivial names in here. Do you see a trivial name? NH2, which is what? Aniline. Okay? So this aniline will be the primary spot that we start going out from. When I have more than two groups on the ring, make a note of it, I have to use numbers now. Okay? So the number 1 will be where my trivial group is, and then I'll go to lower numbers this way. So the bromine would be on carbon 5. So I would then name it as 5-bromo. 2-chloro, and then put on the base name aniline. Okay, 5-bromo 2-chloro aniline. You might ask, well, there's a 1 here where the NH2 is for the aniline. Why didn't you use a number down here? Okay, again, you don't need to, because the aniline is telling you I have an NH2, and by definition, that will always be number 1. So it would be absolutely redundant to put a number 1 right here. Okay? Now, if that was another group, such as a nitro group, then you would have to put a number for it. So something like this. Here you would want to start the numbering so you get the lowest numbering all the way around. There's no priority group. So the best way to number would be to start with the chlorine and come down that way. So this would give us 4-bromo, 1-chloro, 2-nitro, and now benzene. Okay, so now it's named as a benzene because there's no trivial group on that ring. Okay, so this takes care of our naming of benzene molecules. You want to make sure you master this very quickly. Jump on the homework problems and practice, 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 because we're going to be referring to all these different molecules by name. So you'll need to know what we're talking about when we talk about a certain name. So this finishes up chapter 16. Okay, so the big parts of chapter 16 are what? Benzene nomenclature that we just did, and what? Aromaticity that we covered in the previous lecture, and anti and non-aromaticity as well. So make sure you have those two topics down before we move on to chapter 17. 17 is the bulk of our benzene chemistry, and it'll take several lectures to get through this. This is what we want to get into in chapter 17, benzene chemistry. How does benzene react? Okay, with what kind of molecules can it react? Okay, benzene is a stable molecule, very stable. It's aromatic, remember? So can it react at all, or do we have to induce it to react? Okay, these are the kinds of things we're going to study in this chapter. Okay, and I think this will be a good stopping point for us, and we'll get into the things of benzene chemistry during our next lecture.